Okay, so let's start. Good morning, and welcome to the Collège de France and to this colloque. So the Collège de France is one of the most prestigious academic institutions in France. It has been founded by King François Ier, François I, in 1530, and is still a flourishing institution after about 500 years. The Collège de France is an institution dedicated to the promotion of sciences, humanities, and art, and it has a long tradition of interdisciplinary and cross-fertilization. Its motto, as you can see on the slide, is Docet Omnia, which means it teaches all disciplines. The Collège de France created, together with INRIA, an annual chair devoted to informatics and computational sciences. And so you see here the list of the speakers that held the chair in the previous years, and especially Bernard Chazelle, who will give a talk this morning, was one of the very first to talk on algorithm and science. So you see the various topics, and I'm very glad to be the one that has been elected this year to talk about computational geometry. So I see this as a sign that computational geometry is considered by these great people as an important field in computer science, and also of the vitality of the French community. So the two colloques, there will be two colloques, one today and one on Thursday, are the closing events of this course. As Franco Preparata will recall, computational geometry emerged in the late 70s, and since then the field has developed a lot, and its roots and impact extend now far beyond the field of computer science. The goal of this first colloque is to present in an accessible way some of the most promising trends in computational geometry research, both from a theory and an applied perspective. We will see new and sometimes spectacular new developments and a number of new applications in connection with dynamical systems, robotics, statistics, and data analysis. The speakers of this colloque are all outstanding researchers whose seminal contributions have shaped the field. I am extremely grateful that they all accepted enthusiastically my invitation, and I would like to thank them warmly. I hope that this colloque will help establishing new and mutually beneficial connections, interaction with other sciences, and I hope that there are researchers from other disciplines that will attend and interact today. It will be followed by another colloque, as I mentioned, on Thursday, entitled Geometry Understanding in a Higher Dimension, with again a mixture of theoretical results and applied results. The colloque will end with a concert by Agnès Sulem and her quartet. So Agnès Sulem is a colleague from INRIA, and she's both a leading researcher in financial mathematics and a professional musician whose quartet created at least several contemporary works and made several recordings. I hope that you will enjoy concluding the colloque in music. Okay, so here is the program. Tomorrow, there is no talk on computational geometry, but I would like to attract your attention to this exceptional talk by the recent Nobel Prize Chemistry, Nobel Prize Jean-Pierre Sauvage, who will give a talk, and the talk is entitled From Chemical Topology to Molecular Machines. So it has some connection with our colloques, and it may inspire new connection between computational topology and chemistry. Before this brief introduction, I would like to thank the professor of the Collège de France who gave me the opportunity to organize this colloque in such a wonderful place. I would like also to especially thank its administrator, Alain Prochian and Gérard Berry, and also Sophie Benita and Lucille Gurdak, who took care of all the practical matters regarding the organization. I wish you an exciting and enlightening colloque, and I will now introduce briefly the speakers. Thanks. So the first speaker of the day is Franco Preparator, who is a professor at Brown University. Franco has been a pioneer of computational geometry, and this book, co-authored with Michael Chamos, has been the very first book on the topic. The book was published in 1985 and has been for many years the standard textbook in computational geometry and has been translated in Russian, Chinese, Japanese, etc. Franco made several important contributions to the field of computational geometry, but he also worked on very diverse topics, and his name is now attached to coding theory, fault-tolerant computing, parallel computing, VLSI theory, and computational biology. I'm very pleased that Franco accepted to introduce this colloque. So please, Franco.